Hello and welcome to another one of Dee's ADD videos. Today we're going to look at a problem in which a supplier or a product is supplied by three different suppliers, and of those three suppliers they each have their respective probabilities of being defective. This immediately should scream out a factor tree to you because of the fact that we're divvying up the workload between people, and each one of those people have the same thing we're looking at, in this case the defectiveness. So if you were to label your percentages here, would go 24. Actually, middle one would be 36. Big percent sign makes it more reasonable. And the bottom one would be 40. So when you split it up, now this one here, the spot is probability of defective, but it's not just defective, it's defective given that the first supplier was X. And that has a probability of 105. And if we look at the complement, well, these two have to add up to 1, so that should be what? 0.95. Same logic here. Defective given that it came from Y. No one was 10%. Or 0.1. So what the complement there would be, ahead of myself, it seems. Probability of defective complement from Y would be 0.9. So these are all the good CDs, right? The complement of defective is for computers or whatever you're distributing. And this is probability of defective given Z, and that one was 6%. And defective complement given Z equals 0.94. Sorry about that. Alright, so what we need to do is we need to use the product rule for initial probabilities. It says probability of A intersection B is the conditional times the conditional times the condition, sorry. And that would go for any of these intersections. So if I wanted this one defective, I would multiply these two probabilities, for instance. Alright, so the question is, given that the CD or whatever item was defective, what's the probability that it came from supplier Z? Alright, so again, just write it in terms of a question. It would be probability of Z given defective, and that would be the probability of Z intersection D over the full probability of defective. Okay, well, the full probability of defective is all the conditions in which defective occurs. And these are the conditional probabilities, so it would actually be the product of each of those. So, at the top would be the intersection of Z and defective. So in this case, that's how you get the intersection of those two. And then the bottom is going to be all the defectives. So that's going to be probability of defective and X, or probability of defective and Y, or probability of defective and Z. Alright, so all those ors become plus signs, and we got to calculate all those values there. Alright, and if you do that and plug in the numbers, you should get 0.06 times 0.4 over 0.24 plus times. When you do all that, you should get a probability of 1/3. I believe should be 0.024 over 0.072. Alright, hope that made sense. Again, how did I know it was a factor tree? Because there were different suppliers doing the same thing, and they were looking at the same defective rate, or whether we're talking about different banks and their approval rate, different schools and their acceptance rate, whatever it is, something that divvies up the information in that manner. Set up your factor tree. Remember, the last column is just a conditional, so if you want the intersection of whatever two events, you're going to have to multiply the condition times the conditional. And then set up your conditional probability formula, plug and chug, and you should get your answer. Hope that's clarified things. Practice, practice, practice. Thank you and have a nice day.